Hello, can you hear me?
Yeah, I can hear you. Hi there.
Yeah, I'm fine. How are you?
I'm good, thanks. How are you?
Yeah, I'm fine. Thank you. Okay.
Nice to meet you.
Yeah, nice to meet you too. So now where are you from?
From London.
Okay, and what's your university name?
What did you say?
University name.
I can't hear you. Sorry, 1 minute. Let me just sort something out. Okay, that should be better. Sorry, what did you say?
Yeah, so what's your university name?
Oh, University of Leeds.
Okay. And currently are you doing the
Yeah.
masters or PhD?
No, I'm only undergraduate doing geography, but my dissertation is looking at satellite imagery, looking at how you can detect floods, and I sort of went outside the box and did a bit of research and found out that SAR Sentinel-1 was the best way to go about things, and had a few questions basically about that.
Yeah.
And I've been using your videos, which have been helpful.
Okay, thank you. Okay. Okay, so basically you face some problem regarding the issue, such as okay, just
Yeah,
like simply open your message. Just
yeah,
I think you can send me a message in the Telegram, yeah?
yeah. I sent it on Gmail. Essentially, I just wanted to know what your idea is around accuracy assessment, how to test how accurate the code is at detecting the
Okay,
flood.
so did you already make the classification?
Yeah, I just did a simple sort of change detection, got the before image, after image, difference them, and then that sort
Okay,
of highlighted
so
where the
are you
water
use the
was.
Google Earth Engine
Yeah,
platform in this time? Yeah.
yeah,
Okay. Okay.
yeah.
Okay. So in this time, you can use here the different ways. Suppose you can easily make the confusion matrix table, such as use this
Yeah,
confusion matrix table, including the actual value and predicted value. Then we can compare the result.
yeah,
And from the confusion matrix
yeah,
table, we can easily identify about that overall accuracy as well as the Kappa accuracy,
mm,
then producer accuracy, consumer accuracy. All of those accuracy we can
mm,
easily show. Okay. So in this time,
yeah,
you can simply share your skin. Then I check your code,
mm,
full code, then show you that what's the method you need to apply for the accuracy assessment.
yeah,
So
yeah. I can. Yeah. Well, basically, I'm very new to all of this, so my level is very basic. So I was just trying to figure out the easiest way to go about it. I'm going to load up what I've created for one area. Um, but I was just wondering what the method is just to simply, with a land classification, it's so easy just to create random points and then go on Google Earth to see whether that area is grass or urban. But with flood, I don't know how. Maybe there's some like database online or a report where I
yeah.
can test how accurate it is. So let me just see if let me share screen.
Yes. So, let me screen.
Yeah.
And you want to in this time you just apply the thresholding method to identify the flood and non-flood region.
Yeah, simply that. So let me do this. So can you see what I've got here? Yeah.
Yeah, so now if you yeah.
So this is this year. This is just one random flood event. It was the Ukraine dam um, earlier this year, and it's simply it's just very basic code here. What I've done
Yes.
is just simply minus the before and after image to get the difference layer, and then just simply mask it to get the flooded area. Um, and added a few parameters as well,
Okay.
such as slope and permanent water, but that's really it.
Okay, so in this time for that accuracy assessment,
Mm,
first of all we can just collect the some training sample such as
yeah.
flood region and unflood
Mm,
region. Okay.
yeah.
And then further we are just applying a any kinds of machine learning method, such as in this time you are just applying the thresholding and make this type of classification, flooded and
Mm,
non-flooded. But when you want to
yeah.
make the classification algorithm, it automatically separate the two things. Suppose flood region এবং non-flood region automatically separate these two things. Okay. So in this time, you can simply share your code with me. Then I simply try to open and then try to show you that how we can easily make the training sample, flood region and non-flood region, and then apply the machine learning to make that the equities assessment about that.
Yeah. Should I press this one here, get link?
No,
Is that
not
this
here.
one?
You can click on the get link button, not the drop down. Just click on the get link button. Yeah. So now
Yeah,
send me this link.
Thank you very much.
Okay, send me that. I try for that. Okay.
That
So
should, yeah.
just open this code. Share my screen. So now I can stop the sharing. No problem. Just I share,
Yeah.
just share my screen and then.
Yeah.
So now can you see my screen? Yeah.
Yeah, I can.
Okay.
Perfect.
And okay, so this is our difference layer. Okay. So mainly this is a difference layer. In this time, from this difference layer, mainly it's the pre and post. These two conditions you can simply separate the two event, and then we can create this difference layer. In this time, you are just collecting the training sample from here.
Yeah.
And we are already make the flooded areas. You can see this is the flooded areas. You already make this map flooded areas using the thresholding. Okay. So this type of region is the flooded region. So in this time, I simply click on the new layer.
Yeah.
And then click on here. Suppose I put
Yeah.
this thing is that flood
Perfect. Yeah.
was flood area. And then put here the feature collection.
Yeah.
I put the property name, suppose class, and set the value for 0. Okay, so in this time, I just simply take this type of, or if you want, you can also suppose in this time I simply stress it. Then suppose stress is 98%. Then it also better looking about the VA band. Okay, so now the increase the reflectance. Okay. Showing the reflectance ratio just.
Yeah.
And you are considering the pixel thresholding value. So you're just flood marks area. Here we can get that water greater than equal 10. From here, yeah. Okay. Basically, this is our flooded area, and this type of water is the permanent water body for the river.
Yeah.
Okay.
Yeah.
So now for the flooded area, I simply click on here. I just simply take some training sample from here because it's a flooded.
Okay.
And we are just make the classification mainly flood and non-flood region.
I see. Yeah. Yeah.
And then we are just created the confusion matrix table and then just make the accuracy about that. And in this time, it has also another problem. In this time here, you can see, I think it's a river. Okay, so it's a river.
Yeah.
It's a permanent water body. Mainly river contains the permanent water body. But when you apply the thresholding, you can see it show this permanent water body is also considered as a flood area.
Yeah.
Okay, so that's why it is the another problem. When you are using the thresholding, only thresholding, then it not provide you the proper flood area map. Okay. So that's why in this time, this pixel ratio also same with that. So that's why it also considered as a flood region. But from this base map, we can easily identify it's a totally permanent water body. Okay. So this is another problem. But when we make the classification, then we can easily separate all of those things. So mainly from these images, suppose here you can see, I simply open the after flood. Suppose mainly after flood we can get, and after flood this type of color, color identify about that flooded region. Okay.
What about looking at the before flood and looking at the before as well, and then turning it on and off to see the increase? Maybe it's easier like that as well.
Yes.
The bottom layer, the last one.
Yeah. So in this time you can see this is the flooded. Also you can see it's not a flooded area. It's the permanent water body. Okay. But beside this, it's a flooded area. So we are just take the some training sample from here.
Yeah.
Okay. After that, we are take the another suppose another layer. Suppose in this time we consider it's a permanent water body.
Right.
Or permanent water. Mainly it's not flooded. It's all available for after and before. Both of time is available. And set the property such as class and set the value for 1. And then OK. So now I just simply click this type of pixel.
Yeah.
Okay, just we are take some. And if you need, we also increase the training sample again. So in this time, after taking that, two things. First of all, I need to just merge. Suppose just take a variable sample and merge the flood area. It merge with water body.
Okay.
After that, if you want to check how many sample I collect for the flood and non-flood region, so click to the run. So now it visualizes about that how many total. In this time, I need to extract the band pixel value. Suppose in this time we are considering the VH band. So I need to extract the training sample. Mainly I need to create the spectral signature of each point from the VH band. So here you can see that how much sample I can get. I can get 61 sample. Okay. If I did not get the better accuracy, then I also increase the training sample later. Okay. So now from here, I just take a variable. Suppose I call the variable name is the training. Training. And then I call my image. So basically in this time, I use here this image. So mainly in this time, we are considered about that after flood. After flood, what is the image we can get after flood condition? In this time, we are just use this image. Okay. So after flood, you can see this is the after flood. Okay. So after flood, and in this after flood, we are just considering the one band. What's the band? This band name is the VH. So mainly you can already select about that VH band. Okay, so here you can see. So collection, we consider only for that polarization, I guess GRD. Okay. Yes, so VS band, where is it? Okay, you can see polarization. It's stored at the VS band. Okay. So now in this time, we are just starting the pixel value from here. After flooded, dot just put here function reduce region. It's that we need to use here the sample regions, mainly this function extract the pixel sample for each training point. So now make a dictionary, so use here the curly bracket and also set the curly bracket. So first of all, collection. So collection mainly is my training sample, mainly total 61 training sample I consider and store it in this variable, copy and paste. And I set the properties mainly which I set in here. Suppose here you can see the property. I set the property name is the class. So just I use here the class, same property, class. And scale is that 10 meter. And it's not MC remove that. So now I just try to print this training and check about the training spectra or spectral signature for each point. Click on run. Continue. Yeah. So now click on here. Here you can see the feature 61 and it's already stored. Suppose this training sample you can see 0 number class negative 26. This is the band value. Basically it is the spectral signature for this training sample. Also you can see this is the training sample, spectral sample we can get from here. Okay. So in this time we are considering, mainly in this time we can just get all of those training sample for each point. Okay. So then in this time we are just apply the machine learning method and make the classification and then also check about our accuracy. If I did not get the better accuracy, then we also need to increase the training sample. Okay. So let's go. So now this training data set I need to separate into two ways. Suppose in this time I use here the 80% data for train my model, train my model, and rest of 20% data I use for test my model. Okay, just I use it. And now take a variable. Suppose I put the variable is, and it will be I take the randomly. Okay, randomly. So for that, first of all, I need to just take a variable. Suppose data set, and call this training because it stored my full data set. I put here the function random column. So random column. So now it randomly distributed. And now I filtered the 80% data and 20% data. So just take a variable. Suppose I put the variable train set and call this data set and paste here and use the function simply filter. From here I take the art engine filter greater than random 0.8 80% and take the another variable. Suppose test set. I call my full data set and then filter it, filter art engine filter in this time less than equal random random 0.8. Okay, so I separate the two things. Now I just apply the machine learning. In this time we are just classified the two class. So I think in this time we are just applying the support vector machine because for the classification of the two class, mainly support vector machine is the better for that classification. Suppose I just put a variable model and call the model support vector machine. You can see this is a support vector machine. I simply click and then simply copy this function. And paste. And then use here the train function, train my model using the 80% data which is stored in the train set and paste. and then and after that it will be work. So I just simply print. Okay, I need to put all of those argument one by one for this train function. So just I simply make a dictionary and also close the dictionary. And first of all, feature. So mainly feature is that our 80% data which is stored at the train set. Class property mainly is the we put the name as a class. Input properties. So mainly in this time input properties is that our band name. Okay. So mainly in this time we use a band. This band name is the VS. Okay. So just I consider as a VS band. So just put here the VS. Okay.
Yeah.
No, it's not anything of that. It's not it. So now I just simply print my model and check about this status. So print this model. Now run this code.
Yeah.
Okay, so now we can get this classifier.
Yeah.
We can get the input properties is the VS band. We can get the classifier is the support vector machine. We can take the one property is the randomly we can guess. So okay. So now we are just suppose model explain. So mainly this function explain this model about the support vector machine and provide you all of this information about this model.
Okay. Yeah.
In this time, it's mainly two classes we just classified, 0 and 1. 0 identify about that flooded area, 1 is identify about the permanent water body or non-flooded area. Okay.
Yeah.
And in this time, we are considering the total 11 properties. Here you can see about that. So here all of those support vector machine arguments, suppose what is the gamma value or degree, then cost coefficient, theta degree value, and so all of those things we can easily get. In this time, we have put here that you can see CV, this type of, we can kernel type is the linear. So this type of input we can easily get from here. Okay. So now I train my model. Okay. So after training the model, I just make the classification. So for classification, just take a variable.
Yeah.
Just take the variable and put this name, suppose classification. For the classification, I need to call my image. So in this time, I simply call my image and I want to classify it after flood condition. Okay, after flood condition, I just make the what is the flood region and what is the non-flood region. So just I simply call the after filter and paste here. And now check. I simply use a function, mainly this function call that classify, and I need to classify with my model which I already make and paste. And now I just simply show the layer, suppose map dot add layer, and then classification and paste. And I have to two class, so mean value will be 0 and a max value will be 1. And further I just make the plated. Suppose I just show this plated as a list. I just put the flood region as a blue color, and non-flood region I show as a suppose yellow color. Okay. So now click the run. So now you can check about the what is the condition we can get from here. If I did not get the better map, then I need to increasing this training sample. Okay. Because in this time there are a lot of different types of feature is available, such as water body, barren land, build up area. So this type of things is available. So for that we need to also increasing the about that. Okay. So it look like that. This type of color, blue color. So in this time, how I can separate these things? Suppose in this time it show about that all of those things is that for the flooded region. Okay. So mainly in this time we need to increase the training sample. Okay. Suppose in this time all of those pixel in this time you can simply open your flood upper flood this image. So in this time you are not consider only for the water body. Okay. So in this time, suppose water body mainly it's including non-flood region. Non-flood region it can be cropland, it can be vegetation, permanent water body. Lot of feature is including in here. So just you are also take the more training sample for that. You also open these flood areas, and then without flood areas you just take the all of those classes. It including all of those suppose cropland, vegetation, build-up area, all of those things, including as a non-flood region. Just increase this. Suppose you can see it's a mainly issue about that urban or build-up.
Yeah.
Just take this. And it's a permanent water body. So all of those things we are just considered as a non-flood.
Yeah.
Then we will get the better. And okay, suppose all of those things. And is it permanent water body or flood?
Go on satellite and maybe you can see better on the and then turn off the I can't remember so much. Yeah, no, it's not. It's It's
What is it?
just like
It's a flood
agriculture,
or barren
not
land?
flood, barren land. I think.
Yeah.
Yeah.
Yes. Okay, so now try to run it in the code and check. So now we are also get some differentiate, you can see. And mainly it's depend on your training sample. When you want to get the more training sample for each classes, then we also get the better map. Okay.
Yeah.
Okay. In this time here you can see it just show about the flood region and also show about the water body. So mainly we cannot differentiate it. So further we also take the more training sample about this water body. Suppose because it's a permanent water body as a river. So further I simply increasing the flood water body. Mainly it's including all of those classes. Okay. And just paste here. Because it's a permanent water body for a river. Okay. And so mainly this type of things is that other feature. And I also just flood area. I also need to take the more training sample for the flood area. Suppose this type of flood area.
Yeah.
Take the more training sample, then it differentiate. Or when my data set is the big, then this algorithm easily differentiate. It's a flood area. It's a water body because water body and flood area. This spectrum is almost same. So that's why it's very difficult to differentiate.
Very difficult to get the threshold. Yeah.
So that's why we are just take the more training sample about that. Then I hope it will be okay for that classification about.
Yeah.
Okay, so now check again.
I think the issue at the top, I think it maybe I can't remember if it's I don't know. Maybe look before and after the flood. Maybe let me see. I can do it on mine. I just wanted to check. Maybe that is
Yeah, check it.
yeah. I don't know why it comes up with the permanent water body there, but
Suppose we are just take the more training sample. We are considering it's a non-flood region.
yeah. Yeah, very difficult because it's the same, very similar. Minus 27, and then the flood here,
Yeah.
minus 22, so it's very similar. Yeah.
Okay, after that you can see it show over all of those things will be flooded. So in this time we are take the more training sample for that flood region. Okay, so for that I just simply open the flood area and then also increasing the more training sample for differentiate flood area.
To be honest, I think maybe we can cut off the area of interest before that permanent water body, because the flood happened after the dam. So actually, it's not even within that area.
Yeah,
We can reduce the area of interest.
yeah, it also better for that. Yeah,
Yeah.
because mainly this part is flooded area.
Yeah. If you go up, the dam is just before the permanent water body. It's just that it's just a bit more. You see there, bit more further up, right there. Yeah. That's where the flood started.
Yes,
So
it
all
start
of
from
that.
here. Yeah.
Yeah. So we can cut that bit off with the polygon
Yes,
if
then
it's
you can get the
better.
better. Yeah.
Yeah.
Now let's check. Okay. Okay. So now we also get the better things about that. And
Yeah.
basically, this you just simply crop your area from here. Basically,
Yeah.
this
Yeah.
region is must be water, which is almost
Yeah.
same with the your flood water pixel value. So that's why
Yeah.
it's very difficult to
Yeah.
vanish.
Yeah. Yeah. Maybe it's easy to do just in geometry. You just edit, but
Yeah.
I'll
Yeah.
do.
Yeah.
Yeah.
Okay. Okay, so now
Yeah.
okay, so now I'll show you that how we can easily make the accuracy about that. Okay, so now suppose
Yeah.
you also just fix the training sample and also fix the area. After that we are just check about the accuracy. For the accuracy we are just create the confusion matrix table. Just take a variable.
Yeah.
Suppose I put the variable name is the confusion matrix and put here ee dot confusion matrix, and mainly in this time I call my 20% data which I already stored in a variable test set. Simply copy
Right.
this 20% data, I simply call and paste here, and it's classify with my algorithm. I already create my algorithm, my model. You can see this model. I simply copy the model, paste. After that I need to find out the error matrix. So error matrix, and put here that actual value and predicted value. So for that simply curly bracket state and curly bracket int. So mainly actual value it's identify about your class, okay, with property name, okay, and predicted value we are set about that classification, and it's not need, I simply remove that. So now further I simply print this confusion matrix. So print confusion matrix, simply copy and paste, click the run. So now it create a confusion matrix table, and from this confusion matrix table we can easily make the accuracy about that overall accuracy, kappa accuracy, producer accuracy, consumer accuracy. We can easily create from here.
Yeah.
Okay, so it's created. Okay, it's created the you can see the confusion matrix.
Yeah.
So now we are just make the accuracy. Okay, suppose print and call the confusion matrix, and then paste and use at the accuracy. So now click to run. So now it's calculated the accuracy about the overall accuracy, what we can get after classification. So it created. think the 72% accuracy, overall accuracy about this
Right.
flood mapping. As well as suppose you created the Kappa accuracy, and when you want to clip your study area from here, then you also get the better accuracy. In this time, this region is mainly difficult because it is
Yeah.
not easily differentiate the pixel value because it's almost same. Okay, so when you do that, I hope it will be okay. And then suppose Kappa, I can check about the Kappa.
Yeah.
So now it, yeah, we can get a 43% Kappa accuracy and about 72%. As well as if you want to suppose calculate about that producer accuracy, suppose producers accuracy, click to run. So now we can get the is class producer accuracy from here. So here we can get the producer accuracy for water, flood, and non-flood.
Yeah.
As well as suppose I check about the producer accuracy, consumer accuracy. So for that, use the consumers accuracy. Click run. So now we can get the is classes consumer accuracy from here. Just as you can see, for the flood and non-flood, both of classes we can get the consumer accuracy. For the flood region 66 and non-flood 95. Okay,
95,
so basically this is the process for getting the accuracy about the flood area map. In this time, you are just make the crop your study area and then take the training sample. Okay, take the more training sample for each classes. Otherwise, it's very difficult because in this time water VS value and flooded area VS value is almost same. So that's why when your data set is the big, then we can easily differentiate about that. Okay. So I will send you this code. You also try to do that. I hope you can easily get the solution about that.
Yeah. Thank you. I have a question then. So this is with the confusion matrix. This is just comparing the classification and comparing it to what? How does it get the accuracy, that number? How does it work?
In this time, here I use the support vector machine, and this model how properly classified the flood and non-flood. Okay,
based off my original flood mask.
Yes.
So how do I find out how accurate that original flood mask is? How do I test that? Is there like some sort of, because I wanted to see how accurate sort of Sentinel-1 is at looking at floods, and I was thinking maybe to look at historical events, putting the code to a historical event and then comparing it to ground truth data. But I don't know where's the best place
so
to get
for that you need the ground truth data. Suppose in this time you physically go to the visit your study area, and then you just simply take some training sample, specific latitude and longitude for the flood region. Okay. And further you can simply import in here. You can see it also available to the CSV file. So simply import the CSV file and then extract the pixel value from your ground truth data, and then compare with your classification map. Okay, same process we also apply for the. In this time it's compared with that classification map. But when you want to take the training sample, it extract the pixel value from your point, which you can collect from the ground, and then compare this result, and we also get the result accuracy about that. Okay.
And is there a data set online, like a website that has ground truth data of any flood?
Yes.
Where's the best place to go?
You can use here the suppose Google Earth Pro. You can also use no problem. So you can simply use the Google Earth Pro, and then simply you can just simply flood region. You can simply make the some polygon, or you can make the some point or marker and make a shape file about that, or point shape file, and then further use it, and then you can easily do the accuracy about this map.
Yeah, but not for this event. I don't mind. But let's say I want I wanted to find like a report or someone who's collected ground truth data of a flood, and then see whether I can recreate what they found. Basically, is
Okay.
there?
And what's the format
Yeah.
you want to collect?
Well, I don't mind what data it is. It can be someone who's recreated a map along with ground truthing data, or some sort of basically I was looking at like maybe consultant report where they've drawn lines where the flood was, and then I can compare it to my satellite imagery.
Okay, it also possible. So first of all, okay, so for that you have to just digitize. Suppose this map as a PNG file format or photo you have. So first of all, you need to digitize this image. Okay, so you can easily use the ArcMap software or QGIS software for digitizing, and then you can simply make the polygon about the flood area from this map.
Right.
And this
Right.
polygon or shapefile you can simply import in your asset. Okay, and then we are just extract the pixel value only for this polygon or this point. We can extract the pixel value and make the classification and then check the accuracy from here.
Perfect. Yeah.
Okay,
Yeah.
it all
And is
possible.
there any websites, any websites or reports that you know of that have really good data that I can use, that I can do that with?
Okay, so for the digitizing you can, okay, so I'll send you the some link about that for digitizing. How, suppose you have a PNG file format image historical map, so this photo you can easily import and then make the georeferencing. Okay, and then you can simply digitize your boundary of the flood region, and then you can easily do it, no problem.
And
Or if you have this file
Yeah.
PNG file format file, you can also send me. Further, I also share you how we can easily make the georeferencing and also digitizing the flood region, and then how we can easily use it in Google Earth Engine platform. Okay.
Right. Yeah.
Okay,
Great,
no problem.
great.
Okay.
What's the best flood you think to do this for? Because obviously it has to be 2014 and forward because of Sentinel-1. I was wondering what the best sort of event is, if there's one that's been really well reported and it's got good photo.
Yes. Okay, so for that Sentinel-1, SAR data is better for the flood mapping using the thresholding. Okay, and if you want, you can also use the Sentinel-2 also is better. Suppose you want to make the classification, then Sentinel-2 is better. For that you can get the 10-meter resolution for the flood area and non-flood area, and you can easily classify this flood region. Okay, for the Sentinel-2 is also better for doing that.
Okay, great. Thank you very much.
Okay, so I'll send you the link. Also try to check about that and try to fix how to do it. Okay.
Yeah.
Okay.
Yeah.
Okay. Thank you. Okay. Okay. Have
Thank
a
you very much.
Okay.
Yes, I'll text you. Thank you very much.
Okay. Thank
Bye.
you. Okay. Bye.